So Jiva, we've looked at the most common collections that people are going to be using when using Foundation and Objective-C. So we've looked at NS-Array and NS-Dictionary and NS-Set and the mutable versions. But there are some others around that are probably less common in usage, but handy when you need them.
Yeah, there's a couple of new arrays or new collection classes that have been added to Objective-C, mainly due to the addition of garbage collection. When we talked about garbage collection about weak references and how there were cases where you would want to have a collection of objects that sort of maintained itself, so that if you had an object that no longer had a reference anywhere in your application, a strong reference anywhere in your application, that object would be deallocated and zeroed out in certain places. And so Objective-C provides a few collection classes that sort of correspond to our collection classes that we've already been looking at for exactly that purpose. Okay. So let's take a look at a few examples. First of all, we have the NS pointer array, which is basically its purpose is there specifically for storing weak references and C pointers. So this is one of those cases where you can actually insert non-objects into a collection class. That's what these are there for. So in other words, just straight up like C pointers and those kinds of things can actually be put into this kind of a collection. Now, typically, you're going to use this, like I said, for maybe a zeroing weak memory kind of collection, which is what we've got, what we're configuring here. When you create one of these, you pass it a bitwise mask of option flags. And in this particular case, we're passing the flag NS pointer functions zeroing weak memory, which is going to configure this NS pointer array to be a zeroing weak memory pointer array. And so you can do the same thing, like for example, let's say that we wanted to configure a pointer array that stored standard C-style strings that were allocated with malloc, for example. Then you could pass the parameters, the flags, to that same options. You could pass the flags NS pointer functions C-string personality, which is essentially configuring the personality of that array to hold C strings. And then you can also pass NS pointer functions malloc memory, which means basically when an object is removed from that, or when it's removed from that, it will free that memory using free, because the objects were originally allocated with malloc.
Okay, right.
So then, if you wanted to add or remove objects from the collections, you basically just use the same kind of syntax. You've got this add. In this particular case, because it's a pointer array, you're going to do add pointer. So in this case down here, we've got this char pointer that you've allocated. Maybe you've used malloc if you were using the array that we configured up above. Let's say that this pointer was created with malloc. Then you could add that pointer to the array, and then there's also a remove pointer method, and so on and so forth. So again, we're talking about those same kind of patterns, add methods, remove methods, and things like that. But this is there specifically for those special cases where you've got, existing C-style pointers, or if you're working with garbage collection and you need to be working with weak references.
Cool.
So this is the class that's sort of the corollary class to the NS-Array class, right? There's also the NS hash table, which essentially works exactly the same way. It's also it also has all those same behaviors with the zeroing weak memory and things like that. But this particular class corresponds to NS-Set, so it's the same kind of deal, right? Except it's corresponding to the NS-Set, and it uses these C-style pointers or zeroing weak references. Then there's also the NS map table, which also does the same thing, but is the corresponding class for dictionaries. So this is an associative collection, but it's used for like zeroing weak memory with associative types of collections, so dictionary things with keys and values. Now, an interesting thing about that, of course, is that you do need to configure the options both for the keys and the values. So you could mix and match there if you wanted to. It doesn't have to be all the same. And as you can see here, you basically just pass these different option values for both the key and the values.
I mean, going into depth of these is sort of beyond the scope of what we're trying to cover, but actually just knowing that they're there, having an overview of what they're there for, will hopefully if you're ever coming across stuff where you've got to, for some reason, deal with old C-type stuff, we're not suggesting...
Or garbage collection, too.
Garbage collection.
In cases where you need that zeroed weak memory or weak reference kind of situation.
They're there, you can use them. Done.
There it is. Yeah, I mean, I'll say in my code, usually, now I don't do an awful lot of garbage collected code. I do some, but usually when I'm reaching for these classes, usually I think maybe I'm overcomplicating things a little bit, and maybe I'm not reaching for the right tools. There are times when they're definitely the right tool for the job, but I would say that they're a rarely used part of the collection classes.
So maybe if you're thinking you need one of these, first question you should be asking yourself is there a better way?
Right, exactly.
And if not, then these are there.
Right.
Okay.
Now, one other thing that I wanted to touch on that we talked about briefly when we were looking at blocks is the fact that you can use blocks with collections as well, right? So remember we talked about blocks. You can define blocks to be an object representation of a function, essentially. And you can do all kinds of cool stuff with that. You can pass those blocks to other methods. You can you get all kinds of neat capabilities as far as you get the existing environment and stuff like that. So I thought it would be cool to show one of the standard foundation APIs that actually leverages blocks. So that's what we've got here. First of all, we have, well, I'll come back to that first line. First of all, we have this block that we've defined, okay? And it's called map block. And what this is going to do is it's going to do a map operation. If you're familiar with computer science terms, a map operation is where you take a collection of objects and you perform some kind of transform on those objects, and then you get back the result of that transform on each of those objects in another array, essentially, right? So that's a map operation. So what this does is this is a map block. And it takes, as a parameter, it takes an item, which would be an item from our collection. It then takes the index of that item, and then it takes a stop flag. Now, this is a standardized set of arguments based on the method declaration of the method that we're going to call. In other words, it's declared to take a block exactly like this, that takes those parameters. So in other words, whether or not you use those parameters when you're actually using this block is dependent upon your implementation. I'm not actually going to use all of those parameters there, but I'm going to use at least one of them. So, and the purpose of them, of course, is, you've got the item that's passed in, the index of the item, and then this stop flag is in case you want to say, to stop the map, halfway through or something like that. You can set that flag, and so that you can check that flag and stop the operation. Now, the actual body of this block is really just taking the map result array, which we declared up here. Okay, this is going to be the results of our map. And notice that we've used that underbar block syntax, which specifies, do you remember what that specifies?
My brain is racking.
It specifies, it specifies that this variable will be read-write for the block.
All variables are readable,
right?
But to be read-write, you have to declare them.
Exactly.
I had forgotten, I'm going to confess.
That's all good. It confuses me sometimes too. So we have this underbar block statement here that's going to set the map result so that we can actually manipulate that object inside of our block. And so that's exactly what we're doing here. We take that map result and we say add object to that map result. Now, transform obj here is just some fictional function that we've got out there that's actually doing some kind of transform.
Yeah.
You know, let's imagine, for example, that we're doing this with a bunch of, you know, sprites in your game or something along those lines, right? And you want to update their position in your game. Mm-hmm. So you might transform over, or you might take this whole array of sprites and perform a transform where they're updating their position in the game field. So that's what this transform obj does, is it manipulates that object and then returns the updated object. So then we're taking that updated object and we're putting it into that map result array. So to actually perform the action, we come down here and let's say we've got an array. Again, let's say it's that array of sprites or whatever. We actually just use the method enumerate objects using block, and we pass in that block parameter. Mm-hmm. And what that will do is it will iterate over each one of the elements inside the array and use that block that we specified to transform that element and then put the transformed element into the map result array.
So the element in the array becomes the item in the call to the block?
Yes.
In this case, and the index of the array is?
Well, we're not actually using the index of the array in this
so we're not using
block.
it. So
yeah.
it's, in this case here,
it's
it will be passed
simple.
as the first parameter,
yes.
the object, and we're done.
Yep. That's pretty much the gist of it.
That is pretty flexible, isn't it?
It's incredibly flexible. It's really cool because you know, that really lets you almost sort of treat this group of objects and just sort of you know, reach in there and say, just do this stuff to them. And it's really a great illustration of how awesome blocks are.
Cool. So we've looked at some of these advanced collection features and using blocks with collections. Are we done with collections now?
Well, sort of.
Oh, there's a bit more, is there?
Kind of. The next subject that we're going to talk about, you know, we talked about how we couldn't put scalars into collections because they're not objects. Mm-hmm. I mean, of course, we could use those NS pointer arrays or something like that, right? But really, you know, if we want to work with NS array and NS dictionary and stuff like that, we can't put just scalar types into those. So instead, we have to use something called boxing to take those scalar values and put them into objects so that we can use them in arrays and dictionaries and sets. So that's what we're going to talk about next, is boxing with NS number and NS value.
Cool. That's what we're doing when we come back.
Bye.